All right, greetings everyone. Welcome to Tales of the Clever Coyote. I'm Johnny Winn, better known on the internets as Johnny Rugger. There, I'll make you go to the next slide. For the past 2 years, I've hosted a podcast called The Elixir Fountain. Prior to that, I did a newsletter for The Elixir Fountain. So I've been around the community for about 4 years. I've contributed to both Phoenix and Elixir itself. I also have a few of my own libraries that are being used, Chronos and Inflex. Inflex is probably the most popular library that I have ever written in my entire life. And all it does is do like singularization and pluralization of words, which is great. It's like, I can't believe that it's that popular. It's really not that complex. Excuse me. So currently I'm working at a company called Imbala Power Networks. What we do is we build virtual power plants to manage renewable resources. These resources are distributed across large areas, as you can imagine. When you think about managing windmills and things like that, it's not a centralized station like what most people traditionally think of as power networks. When you think of a grid, you have a central power station that is responsible for generating power and then pushing the power out to the people that need it. Well, in our case, we have to actually figure out where all these pieces are and decide where we need to pull power from so that we can actually supply other pieces of the grid. What ends up happening is there's actually like cost involved in that. So and a lot of determining factors on finding that cost. So we have to pull all these resources, run calculations on figuring out which one's the most economically viable to use in the scenario that's being tested. And then we have to send out signals to them at the same time receiving a bunch of messages back telling us what these things are actually doing. As you can imagine, there's a lot of data flow. So the idea of taking advantage of distributed systems is great because we can offload things to servers that are more powerful to handle the complex calculations, as well as having one set of servers that's are handling all our telemetry coming in, telling us what these assets are doing, and then we can kind of have another system that kind of can be a little slower that's just kind of organizing all this data and displaying it to users. Now, today though, I'm hoping to be a storyteller. It's quite noble, I think, but not a storyteller like what you traditionally would think of. Or storyteller in the Native American sense of a storyteller. So the storyteller in the Native American sense is more concerned about the truth of the story rather than the context of the story. The truth is actually in the moment of the story. Now, as we all know as developers, truth is truly based on context, because how many people have answered the question, any programming question out there with, it depends? Depends on the scenario, because I can tell you today this, and this is the truth today. And then you change the requirement tomorrow, and all of a sudden, what I told you yesterday is false, and today there's a new truth. So, this isn't actually a story of any great success. I'll admit that. But it's not a story of failure either. It's really just my story that I'm going to share with you about how I came about writing this library called Coyote. Now, some background on it. Coyote has actually kind of been in my head now for about a year or so. If you're familiar with the Elixir ecosystem, how many people here, because I know I see different faces, how many people have used Elixir before? How many people have heard of Elixir before? How many people thought they were coming to something completely different? Okay, good, we're on target. So if you've heard of Phoenix, which is the big web framework for Elixir, and it's great, it's bringing a lot of people to it, to Elixir. One of the things that I've always kind of not really sat well with me is that, it's the idea that there's this big framework that's kind of handling everything for you. And I kind of feel like there's a better way to do things. Not to say that that's wrong, but different, and that's okay. I kind of see the way that I like to build Elixir applications, and really pretty much Beam applications, is pipelines of data transformation. I get data in, I want to send it off to something else, I want to transform that data and then present it. And I want to make that the very last thing that I do is presenting that data one way or another, whether it's to a database or to a front-end user. And so it's all about the transformation. So to me, the MVC style doesn't necessarily fit that, just because there's a lot of hooks in there. You have to do it a certain way. I don't want to do that. I just want to send a message somewhere, let it do its thing, and then give me something back. Phoenix, on the other hand, I think is a great presentation layer if you're trying to display to the web, because it gives you a lot of the things that you don't want to have to deal with, CSS, JavaScript, and all that sort of stuff. I don't want to have to deal with that on a daily basis. I want to have a presentation layer that can deal with that. I add it in there. I just worry about grabbing data and sending it out. So today, I'm not just going to tell you code. I'm hopefully going to be a storyteller. I'm going to share 3 stories with you. Now, these are Native American folklore stories. And you're probably going to stand up there or sit up there and say, what does that have anything to do with this talk? But if you think a little bit deeper, you might kind of find some patterns that kind of follow those stories and kind of apply to this talk. And worst case scenario, they're just going to kind of break it up and give you something to enjoy for a few minutes without thinking too hard. So let's get started. It's time for our first story, The Clever Coyote. Once upon a time, there was a horrible monster that lived up in the mountains. And he had gone out onto the plains and grabbed up all the buffalo and kept them to himself. Well, of course, nobody had anything to eat because the people hunted buffalo. And so along comes the coyote, very hungry, and says, we have to do something about this. We have to free the buffalo. And the people say, but how do we do this? There's this horrible monster up in the mountains that has all the buffalo. And so the coyote thought for a second. He said, I've scouted out the monster. He has a little boy that lives with him. Well, we can't do anything to the boy. It's a little child. What would we? No, that's not what I'm thinking. The boy must be lonely living up there with the monster. Why don't we give him a pet, and so that the pet can help us free the buffalo? People are like, that's a great idea. What do we send? Let's send a mouse. So he sends a mouse up there. The mouse goes into the mountain. The boy finds the mouse. The boy, of course, loves the mouse. But the monster hates it and drives it away. Says, no, get this thing out of here. So they change their mind and say, okay, well, let's send a bird. So they send the bird. Of course, the monster hates the bird and wants to get the bird out, so they send it away. The coyote thinks for a minute. Says, I'll send myself. I'll go to the monster, and I'll befriend the boy, and I will help free the buffalo. So as he gets up there, of course, the boy immediately falls in love with the coyote, because what little boy wouldn't fall in love with a little dog, especially a lonely boy? But the monster, of course, is furious and kicks the boy and the dog out and says, that's it, I've had enough, you go. So the boy looks at the dog, very sad at this point. Everything he's known is gone. And he looks at the dog and says, oh, you must be hungry. You probably haven't eaten. And the boy begins to cry. Well, when the boy begins to cry, the coyote starts to howl, because that's how the howl of the coyote is actually supposed to calm you when you're sad. Well, what is that also going to do? It's going to upset the buffalo. So the buffalo start getting nervous. They hear this howling. And the more the boy cries, the more the coyote howls. And the more the boy cries, the more the coyote howls. And the more the buffalo gets scared. Well, all of a sudden, one buffalo takes off. And what happens when one buffalo takes off? They all take off. And they all immediately scatter across the world, far and wide, so that all have left the cave. Now, of course, at this, the monster is mad, horribly mad, because now he's lost all his food. He thought he had food for life. And so he goes out and he tries to chase the buffalo. But now they've scattered all across the world. Well, the warriors come in and hide in the cave and wait for the monster to return. And when the monster returns, excuse me, when the monster returns, the warriors slaughter the monster, and so he is no more. And then that is how the buffalo became across the world. So what did I do, and what did I set out to do? We kind of started talking about this already. I knew I wanted to be able to build distributed applications. I want things to be able to run small, tiny applications, push them out to different servers, maybe running on the same server on a different node, or maybe even just small applications. But I want to be able to communicate with these, and I want these completely scalable because their size is small and they can be added to a node cluster, they can be pushed out. This is not something that you can do without actually planning way ahead in Phoenix. If you typically follow the guides in Phoenix, you go ahead and you write it. Next thing you know, you have an application that is central, one monolithic Phoenix application. Now, there's several talks out there that will tell you Phoenix is not your application. Phoenix is just another library that you can use, that you can utilize. But unfortunately, starting out, you basically end up having to build this application unless you know better going forward. So I thought I wanted a framework. I thought I wanted to replace it. I wanted something completely different. But what I realized was that I didn't. Over the course of the last year or so, I realized that what I like is small libraries that do something, that do one thing and they do it well, and that they're responsible for that, and that's it. I don't want to build your system. I don't want to tell you how to build your system. I don't really care how you build your system. I just want to be able to communicate with it. Time for a second story. So this is the coyote and the Columbia. So one day the coyote was walking down the road, and it got really hot. And as he was walking and it got hot, he decided he was going to say, "I want a cloud to cool me off." So a cloud appeared. Well, the coyote wasn't satisfied. So he said, "It's still too hot. I want more clouds. Give me more clouds." And so there was more clouds appeared to try to cool him. Still unsatisfied. He said, "That's it. I want some rain. Give me some rain." So it started to rain a little bit. And it cooled a little bit, but the coyote still wasn't satisfied. He's like, "This is not right. I want more rain. I want it to come down from the heavens and rain down upon me and cool me. I'm so hot." So as the rain came down, and the rain came down more, a creek formed. Well, he put his feet in the creek, but still not enough. So he asked for more. "I want more water. Send me more water." And all of a sudden, the waters came down, and it created a great river. And the river swept up the coyote, and tumbling down this river, he goes rolling, and finally, at some point, he washes up on shore, almost dead, laying there, looks up, and the vultures are swarming around him, and he yells up at them, "I'm not dead yet, go away." And that's how the Columbia was formed. So, how does Coyote work? Now, Coyote can be actually run as a standalone library that works as a lead server, and it has a routing table, and you can add smaller applications to it by connecting into that node, whatever that node is. It can be on the same node or a different node, and then supplying a set of routes so that Coyote, the server, when it gets an inbound request, can then send that off and then take that data and return it back to whatever environment. Now, by default, it uses Cowboy. Cowboy is a Erlang web server that's a very popular Erlang web server, so it seemed like the first place to start, but you don't have to. You can actually make it web-enabled or not. Say you're running a back-end system, you just want to communicate with all these libraries, you don't necessarily have to have a web interface. But as I was doing this, I was thinking, well, if I do it with one, why not make it interactive with Phoenix? Plugged applications are great. They're easy to use. People love using them because they're simple. So why not make Coyote work with anything? And so I did. So it basically works the same premise. The only difference is when you have your lead server, you say it's not web-enabled. So you basically use it as a standard library to route your traffic from one application into many smaller applications. What this does is this allows you to offload processing to various applications around your system, your total system. Now, how is that done? Don't worry, we're going to look at some code now. There's your code. This is so if you're familiar with macros in Elixir, what I did was I actually created a router that all it really is concerned with is a way of giving these applications a way to supply routes, and routes in the sense of I need to know what message you'll accept. And so this little macro right here allows you to put a function call in your client and then actually go through, add your routes in there, it reads them in. Now I use a Coyote client to do this. Now this is our Coyote client here. And basically, if you're familiar with modules, you can use the using macro. You say use and then whatever it is, and it actually brings it in to make it a part of it. So you have things like your module name and things like that available to you. This is actually another macro. It's just a macro that's, it's a macro that you don't actually write the macro. You're just kind of filling in the text for it. Now, the key to this is if you look, we have the name, the nodes, the topology that we want to join. By default, it's the default topology. but we can actually create multiple topologies. So say you bring up an application that you only want things that know how to communicate with a specific topology. You can actually route traffic there, so you can have multiple, you can have a single one. When the client application is started, the very first thing that it does, if you look at that init on 27, it sends to register. That register loops through all the nodes that it knows about. Those nodes come from your config file so that you can actually do any number of nodes. We'll look at that in a minute. Here's our actual register routes where we loop through the nodes. We send a message to the lead server, there's a lead server for each node that tells us which to actually connect to, which is going to service these requests. Now, you can do multiple lead servers. Like in our case, we're actually going to have 3 different lead servers. One of them is just going to be an API, so we're only going to give it certain routes that we want to access through the API. One of them is a Phoenix application, and one of them is a basic Coyote application. Who was in the talk yesterday? 2? Oh, you guys missed it. You really need to go watch that online. Because those people will notice on 86, the get code. Now, one thing that I want to mention about that is we actually, when this application starts up, it reads in this module and then sends a copy of it over to the lead server. And then the lead server then compiles that into memory and then calls the function routes to get the routes for this node. So we're actually passing that data over, or passing the code over and reading it in. Now you can also, in your config file, you can set up a completely different function. As long as it provides routes, it'll call that. Easiest way is to use your routes macro. Now, that's great, but what happens when the server goes down? Well, here we're going to actually watch for the server. So our lead server, we actually keep an eye on, and if it goes down, if we get this down message, we actually start continually pinging it to see when it comes back up. Now, one of the things that I talked about was actually adding we don't necessarily need to ping it constantly. Let's wait and ping it, every couple of seconds, because it's probably not going to just immediately jump up. But the idea is if you look up on it's easier for me to look at line numbers over here. 39, that's where we're pinging that node to see when the node comes up. As soon as the lead server node comes back up, we actually re-register our routes because it's assumed that they've been cleared out, they're not there, so we re-register the routes. Now, our Coyote server. When we try to register with a server, on 29, we'll get the message to register. Now, we read that code in with that code load binary on 30, and then we add those routes to the route bridge. Now, the route bridge actually uses the topology that you've specified default by our, there's a default by default, topology, and that's where most of the routes go unless you specify something different. Now, that routing table will actually, when the request comes in, it checks the routing table for a route. If it knows how to service that route, it sends the message over. If it doesn't, then it sends back a message saying no route available. So if your client application drops off for whatever reason, it clears all the routes that were associated with that process and or node. So a process can go down, you can lose just those routes, or the entire node can go down and you lose all the routes for the node. When they come back up, of course, it re-registers. Now, if you're not familiar with GenStage, which is a way to handle back pressure, I debated long and hard before I put this in here. So this has been out now for a little while, but when I first looked at GenStage, I was like, well, do I really want to add it? Do I really need to have this? Because the idea is that you kind of queue up requests and you can handle a certain amount at a time, say 10 requests or how many ever you configure it to handle. And then when it gets back pressure, it kind of delays sending those messages slightly so that way you can wait till it clears up. So you're never just bombarding your system with messages. You're kind of letting them taper in, and so you can actually get a nice throughput. Well, when I first started doing this, I was like, well, I'm just spinning up request handlers. So when a request comes in, I spin up a process. It shouldn't be too much of a problem. And really, when my first passes on this, everything was fine in basic applications. Now, the test that we're going to see where we figure out that, hey, maybe this is a good idea, we'll get to that a little bit later when we actually see this thing running. But needless to say, I decided that it was a good idea to add this in, to deal with the back pressure. When you're talking about something that's handling multiple requests for multiple things coming in from many clients, returning information from many clients, many other possible ways of getting into Coyote. Say you have multiple applications accessing the same lead server to display data, you're going to have a ton of requests. So dealing with back pressure was a major thing. So now, how do we do that? Actually, I decided to go with the consumer supervisor. So when a message comes in, it actually spins up a new request handler, but it is actually queued up. Here, first, they're actually queued up by our relay. So the message comes in, it gets queued up, and then sent off. If that back pressure gets too much, it waits, it delays before it actually starts sending things. But when it does send, it goes on to our consumer supervisor, which is actually going to spin up a request handler for each individual request. Now, here's a big chunk of code, and I don't necessarily expect you to grasp the whole thing, but it is pretty simple stuff. The request comes in on the request handler. Each process handles a single request on its own. It goes, it checks the topology for a route. If it has a matching route, then it sends a gen server call to the particular PID that's registered with that route and whatever message it was that it received. If a response comes back, then it actually relays that response. If not, it just says there's a routing error, there was a problem. And if nothing comes back at all from the route bridge, it says there was no route error. So you actually do get some feedback. Now remember I mentioned that in our client config, we can set up multiple leader nodes. And so in our case right here, we actually set up web, API, and server. So this will actually register all those routes, or all those lead servers. Now, it's only fun if you can actually build a client application with it. This has actually kind of grown a little bit, but this is a simple application where we have what I call Deadwood, and you'll notice a lot of these projects have Old West references in them. But the Deadwood Saloon, we basically have the story of the clever coyote starts out. And so when we get an inbound route in our routes for get/, we know that this is the client that's going to handle that. And essentially, remember, our Coyote client is just another gen server. It just has a lot of boilerplate in there for you. So you could use gen servers to route these messages to directly, but there would be a little bit of cruft you'd have to deal with. So our call is there, and our call is going to get that message, do what it's supposed to do. In our case, we're just returning some text back, and then the server will then relay it to the thing, or to whatever the caller was. Now, in this one, what I actually did for this Coyote client was I specified a different leader node than what's in the config. So in this case, we're saying that we only have the API is the only server that we want to register these routes with, so that way because it doesn't care about anything else. It just wants to service these requests. And then, of course, we're going to build our response. Now, this one's actually a little more interactive, where we're going to use Postman to kind of relay the post and the gets from it. So, let's demo. Y'all ready for a demo? Everybody all right? Everybody on board with where we're at right now? Any questions, comments, concerns? Nobody? Nobody? All right. Okay. All right. So here we go. Mm-hmm.
Could you explain a little bit how, and this probably, if it's out of your talk, just tell me, we'll talk later, but can you explain how the back pressure actually works?
I can. Let's talk later about it.
Because you mentioned it, and I was like, okay, maybe this is too.
Yeah, let's talk about the simplest, it's like a queuing system.
I know what it is.
Okay.
I just want to know how does it work out of the box?
Yes.
Do you configure it? How do you?
It kind of works out of the box, but it is also configurable. So like there's like a set, like 10 requests out of the box is what it deals with. So, but you can change that however you want as far as the number that's actually going to queue up before it deals with it. I know I debated on how much gen server to talk about because I wasn't sure the level of where we were all at with Elixir here, but all right. So here's what we have. We have our 4 sessions set up. If you'll notice, we have Coyote, which is our basic Coyote lead server. It's using Cowboy. It's out of the box. If you just wanted to have an application that was just relaying data out to the web, you could use that one. Down we have Cripple Creek in the lower left. That is our Phoenix application. And then in the top right, we have Dodge City, which is our API using Maru. Maru's basically, if you're familiar with Grape, the Ruby library for building APIs, that's kind of what it mirrors. And then in the bottom right-hand corner, we have Deadwood, which is, as we know, is our client application we're going to be dealing with. So let's start this up. We're going to start up our lead servers. And we registered we started our client application too. If we go over to here, so this, let me just slide it over. Here's our pretty Phoenix application. As I said, you can deal with CSS quite easily with it. And here's our Cowboy application. I intentionally did not put any CSS in the Cowboy application just so that you could tell that there's a difference. Now, these are both being serviced by the same client, Deadwood. As I showed you before, that we have the client that actually just relays the text back. There's not a whole lot to it. There's some links to some of our stories. If we go back, here's our clever coyote. Of course, all this stuff works wonderfully. So those are two applications being serviced by the same client. Now we also have, like I mentioned, the API, which, slide this over here, Postman. So if we send this request, we see we have a hamburger and we have a hot dog. That's the food that we can get. We have two items. Now, if we do a post, I went to a restaurant, $500 for Norwegian salmon. I think that sounds cheap. I think that's good. So if we post this, we'll see that our response was we get our params back, and then we get it's actually added to the list. But and I'll show you in just one second, if we try to go, to one of these other routes, it was food, right? Is what I did. Yeah. Food is our route that we're trying to go to. It's not there because it doesn't know about that part of the application. Even though they're the same client application is servicing it, those routes were not registered with this server, so it has no idea. Now, what happens when our client goes down? No matching routes. Our client went down. We have no way of knowing when it's coming back up or anything like that, but we just know that we don't have that route. Now, when it comes back up, it's back. It's re-registered. We did not have to restart our server. Now, in the adverse, if we bring that down, and it pops back up. Once the lead server goes down, it comes back up. The client application realized that the lead went down, started watching, and as soon as it came back up, re-registered its routes. Everything kind of works. I mean, one of the big things that you have with Erlang and Erlang systems is the idea of this fault tolerance, to where if something goes wrong, it should be able to kind of recover for itself. So if we build applications that are aware of that and say, hey, look, there's a good possibility that something might go down, let me watch it, and then figure out how to resolve the problems on our own. So our other application comes back up, says, hey, it's up, I'm going to go register. Now, of course, there's other problems that could come up, but this is a nice way of knowing that either side has gone down, and so when it comes back up to re-register. Now, our final story. The coyote and the skunk. The coyote, as he was traveling, decided he was very hungry. But he couldn't do it alone, and he saw the skunk and he saw some prairie dogs playing. So he got an idea. He said, "Skunk, my friend, my brother, help me get these coyotes or help me get these prairie dogs, and we'll split them up and we'll eat wonderfully tonight." So the skunk said, now he knew that the coyote was a trickster. He said, "Okay, I'm in. Let's see what you got." So the coyote says, "Okay, you go over there and play dead. I'll take care of the rest." So the skunk goes over and plays dead. The coyote goes over to the prairie dogs and says, my friends, look, our enemy is dead. He lays there on the ground. We should celebrate." And of course, all the prairie dogs at first were a little apprehensive, but then they were like, "Yeah, we should celebrate." And he said, "You should dance around him, but only do it with your eyes closed, because if you look upon it, you'll die too." So they were like, "Okay," because prairie dogs apparently aren't the sharpest animals on the prairie. They start dancing around with their eyes closed. Well, the coyote walks up and kills one. They all open their eyes and says, "He must have opened his eyes. Dance again and keep your eyes closed. If you open them, you'll die." So as the prairie dogs started dancing again with their eyes closed, the coyote picked them off one at a time until they were all dead. Now, of course, the skunk and the coyote were very happy at this point because now they had plenty to eat tonight. So they said, "Let's go up the hill and we'll roast these and we'll eat." Now, the coyote wasn't quite satisfied because, of course, he wants the biggest portion. So the coyote says, as they were roasting the prairie dogs, "Let's have a race. Whoever wins the race will get to choose the prairie dogs first, and then the other one will get the leftovers." Well, the skunk wasn't stupid. And so he said to the coyote, he said, "There's no way I can win a race with you." He said, "You're much faster than I am. You're going to get around, or you're going to get down there and back before I have a chance. Of course you're going to win." So the coyote, seeing an opportunity, says, "Well, how about this? I'll race you. I'll tie a rock around my leg so that I run slower. And that should kind of equal it out." And so the skunk says, "Okay, if it's a big enough rock, I'm in." So, of course, the coyote goes to tie a rock around his leg. And as he's doing it, he says, "Skunk, you go ahead and go on, and I'll catch up." So the skunk starts off down the hill. As he gets down to the hill, of course, the coyote now, by this point, has got a rock tied down and starts running. The skunk sees some bushes and hides in the bushes. He said, "I got this." So the coyote's running and running as fast as he can, but the skunk is nowhere to be found. And as he's running, the rock kind of starts falling off and falls off his leg, and of course, he picks up speed. As soon as the skunk sees the coyote pass, he goes back up to the hill, sees the roasting prairie dogs, and decides to take them off the roaster. They're done, takes them off, takes them up to the hill, but leaves two of the skinniest, boniest prairie dogs in the fire. And he goes up there and he sits and starts to eat. Well, the coyote comes back and thinks that he's won the race because skunk is nowhere to be found. But he also notices that the prairie dogs are gone. And he's like, "Somebody must have come and stolen our meat." Just about then, the skunk appears at the top of the hill and throws the prairie dog bones down and says, "You tried to trick me. You thought you were going to get all the good meat because you knew you were faster. But this time, I tricked you." So what are some of the takeaways of this? Now, one of the things that developers love, although they talk horribly about, is cleverness. Because how many people have written clever code? How many people are lying about writing clever code? Oh, yes. Everybody writes clever code at some point. There's some time that you go to writing something, you get your kind of blinders on, you're like, "This is going to be the coolest thing that I've ever written." And then you write it and you commit it, and then like 6 weeks later, you're like, who wrote this? Where's get blame? Uh-oh. And it was you. So we kind of have to be careful with our cleverness. There's a lot of little clever tricks that Coyote is doing in our library, or in my library. But it wasn't necessarily intended to be clever. I am utilizing some things that are built into Erlang, leveraging those. But I was actually trying to be clever with how I handled things as far as like communicating between nodes and things like that, reading code in. Now, it is a do-it-yourself library, which that's where the cleverness comes in. A lot of times we look and we say, I can do this myself. But there's benefits in doing it yourself sometimes. Doing it yourself allows you to learn it. That doesn't mean putting it in production. It allows you to take a look at something that maybe you're not familiar with and apply that knowledge that you learn from building it into something else so that you understand it. If you're going to use a framework, if you've never built a framework, if you've never actually seen some of the problems that come to the people that build frameworks, you're not going to really know what to do when it goes wrong. So you're gonna have a very high level of it. So there is some upside to doing it yourself, of the fact that you're getting exposed to these new ideas, these different ways of doing things. I know when I first came to Elixir, one of the biggest things that drew me to it was my curiosity. Every developer, I believe, is curious at the core. That's why we're here. That's why y'all are in this room. Because if you weren't curious, you probably would have gone to another .NET talk or some other .NET type talk while we're there, or be out there. But you're in here. So the curiosity is a thing that we all build with. Now, do you need Coyote to do distributed systems? Do you need Coyote to do message passing? No. There's things like RabbitMQ. There's many other solutions out there that you could rely on that are time tested and have been around. But they're also large and robust. They do a lot of different things. Whereas something like Coyote specifies on one, or is specific to one use case of dealing with message passing between nodes, using the request response. So I think if there's one thing that I try to talk about the most is keeping that curiosity alive when we code. We tend to get in our blinders on of work where we're trying to just get things delivered and get things pushed through. But we need to take the time as developers to kind of to indulge in those curiosities, to write those other libraries to see what else is out there and kind of broaden our knowledge of how things work. In some respects, the 3 stories that I told are very relevant to this talk. Did anybody see how they kind of matched up? Nobody? So the first story, we talk about the clever coyote. He decided he was going to help the world. He was going to bring everything that everybody needed. And that was his gift. Kind of like when I first started, I knew I was going to bring something that was going to change the world. But really, it was just a library that gave me some experience. Our second story was getting greedy. The greedy coyote just wanted more, 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 never satisfied until he almost drowned. Well, when I first started down the path of writing Coyote, I thought I needed more. I needed this feature. I needed this feature. My cleverness got the best of me, and I started pulling things in to the point where I realized that, oh, this is too much. I need to pull back. Now, the third story, the most important story of it all, it was just the ending. I'm Johnny Winn. There's the Elixir Fountain link. Feel free to come check out the show. We have guests from around the development community. We're not just Elixir. We do, although mainly we focus on it. A lot of our conversation is around functional languages and functional design of applications. You can check out Coyote on GitHub. I know this is confusing, but I'm NURUGGER07, NuRugger07. That'll tell you when I got on GitHub. And then the GenStage library, there's a link to the GenStage library if you want to check that out. Any questions? Good. I'm done. Thank you all.